Welcome. This podcast is the virtual lab for the thermal decomposition of baking soda. I'm Miss Mikesell, and I'm one of the chemistry teachers at Eagle Crest. Your task in this lab is to determine which of the 4 different balanced chemical reactions it can explain how atoms are rearranged during the thermal decomposition of baking soda, sodium hydrogen carbonate. So there are 4 possible things that could happen when baking soda decomposes. It could turn into sodium hydroxide and carbon dioxide gas, or it could turn into sodium carbonate, carbon dioxide gas, and water, or sodium oxide, carbon dioxide gas, and water, or finally it could turn into sodium hydride, carbon monoxide gas, and oxygen gas. Your job is to use stoichiometry and your experimental data set to determine which reaction, 1, 2, 3, or 4, actually occurred when baking soda decomposed. So again, there's a pretty large and essential question in this lab. You need to identify and claim your experimental yield, and then identify the balanced chemical equation that represents the thermal decomposition of baking soda and claim the theoretical yield. Finally, calculate and claim your percent yield and percent error to prove the validity of your choice. If your percent error is not valid, provide a comprehensive error analysis. Before you begin, please make sure you identify by circling which product you'll be able to isolate and measure at the end of the experiment for each possible reaction. So hint, think about states of matter. And at the end of the experiment, when you take the evaporating dish off the Bunsen burner, what will you have left behind? When you're doing your stoichiometry, you'll need to think about what formula that product represents so that you can accurately account for it mathematically. The method for this lab is as follows. Determine the mass of the evaporating dish, and then add baking soda to the evaporating dish using between approximately 2 and 3 grams of baking soda. Then record the mass of the evaporating dish with the baking soda. Finally, light the Bunsen burner, adjust the flame so that you have an inner blue cone and an outer blue flame, and place it on the ring stand so that the outer blue flame will be in contact with the bottom of the evaporating dish, moving the Bunsen burner to the side. Place the evaporating dish in the clay triangle, start the Bunsen burner underneath with the outer blue flame in direct contact, and set a timer. You want the Bunsen burner to heat the baking soda in the evaporating dish for 7 to 8 minutes. Once that's happened, you can turn off the Bunsen burner and set it to the side and let the evaporating dish cool on the clay triangle for 3 minutes. Finally, when the evaporating dish is cooled enough to touch and carry, measure the mass of the evaporating dish and the product. So you'll need to collect the following data: the mass of the empty evaporating dish, the mass of the evaporating dish with the baking soda, and the mass of the evaporating dish and the product that remains. From that data, you should be able to calculate the mass of the baking soda, the sodium hydrogen carbonate you reacted, and the calculated mass of the product that was formed. And again, think about what that product represents in each of your 4 possible balanced reactions. To do that, you really need to think about states of matter. So if you were absent on the day of the lab, you can gather a virtual data set using the video below. So we can see the evaporating dish. You can get the mass of the empty evaporating dish, 44.33 grams. Now we're going to add baking soda, sodium hydrogen carbonate. And according to the lab sheet, we wanted approximately 2 to 3 grams of baking soda. Please record the mass of the baking soda and evaporating dish, 47.47 grams. We can see the baking soda is a solid white powder in the evaporating dish. And I'm just kind of shaking it around to make sure that it's nicely evenly dispersed on the bottom of the evaporating dish so that it has the greatest surface area when heated. We're going to turn on the Bunsen burner, and again, we'll adjust it so we have a nice tight inner blue flame as well as an outer blue flame. We're going to put the evaporating dish in the ring stand, and then we're going to put it under the Bunsen burner, making sure that that outer blue flame is in contact with the evaporating dish. This will start the thermal decomposition using heat of the baking soda, and just setting the cell phone timer for 7 minutes because we need to let it decompose for about 7 minutes. So when the timer goes off, we'll turn off the gas. All right, it's been decomposing for about 7 minutes. Now we're going to turn off the gas, and then we're going to use some tongs to remove the evaporating dish from the ring stand, since the metal will retain the heat, and let it cool on the counter for about 3 minutes. Now that we've let it cool, we can gently check by just putting our hand over the top of it to make sure that it's not hot, and then picking it up and getting its final mass. We can see that the mass of the evaporating dish with product is 46.31 grams, and that product still looks like a solid white powder. Not much overt signs of a chemical reaction except that change in mass. Okay, your task now is to do 4 calculations. You're going to use stoichiometry to determine which reaction is the one that actually occurred in the experiment. Show your work for all 4 reactions. Your work should confirm one of the reactions and rule out the other 3. From your calculations, make sure to identify your experimental yield from your data table and your theoretical yield from your stoichiometry. Then use those to calculate your percent yield and percent error. And then you can write your claim. Your claim should answer the essential question from the lab. If you have any questions, please email your teacher. Otherwise, you can turn your lab into them when you have completed it. Have a great day.